If there's one feature in Azure networking that gets traditional network engineers excited, it's ExpressRoute. And that's because under the covers, there's a lot of BGP happening. Despite ExpressRoute being a relatively early technology in the life of Azure, it's still used by nearly all of our large customers on the platform. And therefore, the sub-feature called ExpressRoute FastPath is naturally cropping up in a lot of conversations. And because of that, I wanted to make a video on it, explain what it is in simple terms, show you it working, and also show you the scenarios where you should be thinking, oh, maybe ExpressRoute FastPath could help me here. Maybe it could improve performance and unlock that particular workload that I need to run in the cloud. So let's just baseline our understanding of ExpressRoute and agree on terminology. Inside of the blue box, that's my Azure VNet that lives in the Azure region. And in real simple terms, I've got a virtual machine that lives in a VNet. In this diagram here, it's in the same VNet as my ExpressRoute Gateway, which we'll come on to. That distinction is important. I've got an ExpressRoute Gateway, and that's a resource that you deploy as a PaaS resource. You get to choose the shape and the size of it. Think of that as a software router that lives in the VNet. On the south side, it contacts your virtual machines and lets them talk out of the VNet. And on the north side, well, actually on the east side in this diagram, under the covers, it talks BGP to the Microsoft Edge network where the ExpressRoute circuits live. So the green box here is a point of presence in our Edge network, one of the 100 POPs around the world. And typically that's represented by these purple triangles with green dots. That's an ExpressRoute circuit object. Normally you would take circuits in multiple POPs for a enterprise-grade design for resilience. Again, we could talk at length about this, about ExpressRoute circuit shape, size, etc. But for the sake of this video, just know that this lives in the Edge network, and actually what a logical ExpressRoute circuit is just a instantiation specific to that customer on physical edge devices called MSEE or Microsoft Enterprise Edge routers, and they connect the Microsoft Global Network on the south side to customer networks, and on the north side back into our global network, which then goes off to all of the various regions and POPs around the world. And the bit that we're going to zoom in on, because it's the area within which we apply the FastPath configuration, is this line here, the red dotted line, and that's a connection object. And you can think of this as the thing that links the gateway in the VNet to the circuit in the POP. So it connects those two things together. And this is not a one-to-one relationship. You can have more than one gateway connected to a circuit, and you can have more than one circuit connected to a gateway, depending on your design requirements. And you can do that up to the various platform limits that exist. Let's go down a level deeper. Let's imagine a typical scenario. I've got a VNet at the top with some sort of workload in it, virtual machine in this case. It may be peered or it may be in the same VNet as the ExpressRoute Gateway, which is then connected to a circuit. And we talked about FastPath being set there. That circuit, that ExpressRoute circuit, is either being delivered in conjunction with one of our partners or not. You can actually deliver ExpressRoute circuits on top of your own dedicated port. We call that ExpressRoute Direct. And again, that's an important distinction, as we'll come to see later when we're talking about FastPath. And then from that partner or your own physical equipment, you come back to your on-premises network. And that could be via an MPLS WAN, or it could be via a point-to-point connection. I just want to call out a few things on this diagram. Whilst I'm showing you that ExpressRoute connecting to your data center, of course, as we saw in previous videos, we do also use ExpressRoute inside of Azure to connect workloads such as Azure VMware Solutions and SkyTap. And we also offer solutions with other CSPs like Oracle, where we can interconnect to fast connect circuits in kind of a back-to-back connection. So how would a normal flow work here? Well, let's think about an on-premise device sending traffic into a VM in Azure. That traffic would come into the wide area network. It would then get routed to partner or ExpressRoute Direct port. It would come into the Microsoft Edge network. And then based on whichever gateway in whatever region is advertising the destination subnet, it would then go across that ExpressRoute connection Behind the scenes here, this is just kind of BGP happening that's behind these logical objects. And some of the posts by the likes of Jose Marino have shown you how you can debug and unpick some of this behind the scenes interconnectivity using the CLI. I'll leave a link to that below. Now, when it gets to the gateway here, the gateway will then send the traffic to the back-end virtual machine. Now, it's important to know that this gateway object here is in itself a resource, and it comes with considerations. It comes with a sizing that you have to pick. We'll talk about the SKUs in a little bit. You get to pick between these different SKUs, whether or not it's a traditional gateway or an AZ gateway. So that dictates whether or not it's deployed across availability zones under the covers. But normally the lever which customers are most interested in is this sort of what bandwidth do I get? And you can see you can go from 1 gig, 2 gig, 10 gig. But it's also important to recognize that there are other limits associated with these gateways. And that comes in the form of connections per second, packets per second, and the supported number of VMs. We can think about what ExpressRoute FastPath is and why it may be useful to you by thinking about that gateway's characteristics. So if you need to go beyond the scale perhaps of even the biggest gateway, what if you need beyond 16,000 connections per second or beyond 10 gig, right? Or beyond 1 million packets per second? What is the unblocking for you there? We should also recognize that, as I'll show later, when you pass through that gateway, you do add a little bit of latency as that ExpressRoute gateway acts as an IP forwarding device before the traffic goes to your virtual machine. So that will add a bit of latency. And there are scenarios on Azure where you want the absolute lowest latency, the best possible performance. So what if we could send traffic when it came into that ExpressRoute circuit, when it came into the Microsoft Edge network, direct to my virtual machine inside of the Azure region, bypassing the gateway, not having to worry about connections, bandwidth, packets per second. The number of VMs is still relevant, even when using FastPath. That's ExpressRoute FastPath in a nutshell. I want to show you it working, the impact of it, how you configure it, and I also want to talk about the caveats that are currently associated with the product. Okay, let me show you the test topology. Azure region here, it's Azure West Europe. Inside of Azure West Europe, I've got 2 VNets. I've got a green VNet and a red VNet. One's called FastPath on, one's called FastPath off. Inside of that VNet, and of course VNets in Azure span all availability zones, 1, 2, and 3, 2 ExpressRoute gateways. I've chosen a particular SKU and I've pinned those gateways inside of AZ1. I've also deployed some virtual machines, and again, I've pinned those VMs inside of AZ1. I'm keeping my test parity between red and green as close as possible, because depending on what AZ you use, right, the envelope within which we build AZs is up to 2 milliseconds, so I don't want to skew the test based on the actual destination AZ. Inside of each of those VNets, I've got a gateway, and they're both connected to the same circuit. They're connected to a circuit in the Amsterdam POP. Azure West Europe in and around Amsterdam. POP is in Amsterdam, so pretty close together. My circuit then takes me back to my on-prem, which is located in Paris. So bear that in mind when you see the latency. On one of these gateways and connections, I've enabled FastPath, and on the other I haven't. Here's my gateway with FastPath turned on. You can see I've picked a certain SKU. I've picked ERGW3AZ, which is important because if we look at the About ExpressRoute FastPath documentation, which we'll revisit in a second, you can see that you need to use either the ultra performance SKU, the 10 gig SKU for non-AZ, or the SKU I'm using, which is the 10 gig SKU where the underlying data plane is spread across availability zones. And we can see that I've got one connection, which is connected to my circuit provided by Intercloud in Amsterdam. And importantly, if I look at my connection configuration, I've got a tick box there for FastPath. Conversely, if I look at my other gateway, again, same SKU, but because I'm not using FastPath, this could be effectively any SKU, but I wanted to keep the gateways the same. One connection with FastPath turned off. So as a baseline, we can test from my virtual machine on-prem the latency that it's getting to both machine that's sitting behind a FastPath enabled connection and the one that's not. So pay attention, 10904 is the green with FastPath on and 1104 is FastPath off. I can jump to my host here in the Paris data center. I've been running this ping for a while. You can see nominally there by looking at the pings, this one is better just by looking at it right. But I've been running this for a long time now. Let me stop it. You can see that over a period of 10,000 ICMP packets, I've got about half a millisecond of difference there. And based on my testing, that's roughly what you would expect. So what does that actually mean? So switching back to our diagram earlier, when that packet goes up and down the stack here, what we're effectively saying is when that traffic bypasses the gateway, which means it doesn't have to go down the stack and up the stack on another Azure node for IP forwarding, I'm saving about half a millisecond. Might not sound like a lot, but there are plenty of scenarios where you work on designs in Azure, especially where you're using services like AVS and connectivity to Oracle backends, where every millisecond of latency counts. One thing that is important to call out, even though it's somewhat implied by our discussion so far, is that even though we are bypassing the gateway from a data plane perspective, the gateway is still there for a control plane perspective. So when you're calculating your expected uptime and your SLA, etc., the gateway is still there. It's still a resource that you deploy and you pay for. We can show that it's still used for control plane in the normal way by having a look at the CLI output for the ExpressRoute circuit. So here I'm taking the circuit we've been using, I'm passing this command here that lists the routes that I'm learning. And we can see that I'm learning my VNet prefixes, the 10.9, 10.11, which represent my testing ranges. I'm learning them on the circuit level with a next hop of AS65515, which is my gateway, and these next hops are my gateway IP addresses behind the scenes. Effectively, what I've just done there is I jumped on my circuit and I looked at the BGP routes, and yes, I am getting routes from the gateway which represent my VNets. So that it's still an object that you have to deploy and use. Okay, I mentioned it earlier, but let's now look at this through the lens of latency. For sure, you might bypass the gateway because you want particular performance, or maybe you've got a 100 gig ExpressRoute circuit with 30 gig VMs and you want that beyond 10 gig throughput. But let's talk about latency and availability zones, because what you can see here is I pinned all of my test resources in AZ1 to ensure I am taking the AZ element out of the discussion. So I just want to touch on this lightly, but I'll leave some breadcrumbs to learn some more. Because if you work with Azure, you'll know that sort of constructs behind the scenes in terms of how we build the regions. And we talk about this publicly. I'm going to show some screenshots here from one of Mark Rusinovich's talks on inside the Azure Data Center architecture. So let's take a look at this one. And this is where we're given an overview of the France Central region, talking about location of the AZs and these things called RNGs. So you can see in this particular region, Zone 2 is some ways geographically tens of kilometers from Zone 1 and 3. The RNGs, the regional network gateways, are actually nearer Zone 2. What does that mean? Well, if we flip to another slide in the presentation that Mark gave, we can see that on the left-hand side, we've got the Azure regions, and they are made up of collections of availability zones, which are then made up of collections of data centers. And then we have these things called regional network gateways. So they effectively connect the Microsoft WAN, which goes off to the public internet and edge sites where ExpressRoute is, to the Azure regions. So if you combine that knowledge there with this knowledge here, what you can infer is that you may get lucky or unlucky, right? Depending on your AZ that you're using. Because if I'm in an AZ that is closer to the RNG, which then connects me onwards to my ExpressRoute POP, I'll get a lower latency. And this is quite a common thing that happens in customer deployments for low latency workloads. You might do some testing in your own subscription to work out which one is giving me the best performance. And then under the covers that may or may not be related to that, it's actually closer to the RNG or not. And again, just to zoom out a little bit, this is all sort of empirical testing that you will have to do for yourself. The exact latency that you will get, right? It's subject to change We do share the figures that we design too, such as 2 millisecond for a region, 1 millisecond for an AZ. But again, this is not something that's currently backed by an SLA. And then another thing which I'll call out is don't assume that AZ1 for you is AZ1 for me. And in fact, the AZ1 nomenclature in your subscription will differ between even subscriptions in your tenant. So the actual underlying mapping of AZ1 to physical AZ1 behind the scenes, and that differs. We have to ensure a good mix of deployments across the available resources. Okay, so we understand now what the service is and how it works and the performance benefits that it can bring to us. So you might be asking, well, why don't I just turn on ExpressRoute FastPath everywhere if I have these gateways? And the answer is, well, there's some limitations and preview features we need to be aware of. It's not a huge document, but let's go through it carefully and understand it. And then with that knowledge, we'll have a look at some customer scenarios and see how they use FastPath. So first thing is, it's available on all ExpressRoute circuits. Okay, that means I can use it on partner circuits and ExpressRoute direct circuits, regardless of the bandwidth and the SKU type. Public preview for support for private link connectivity over FastPath is only available for ExpressRoute direct circuits. That means if you're coming into the virtual network, going towards a private endpoint, FastPath will only work for ExpressRoute direct circuits. You need to be an ExpressRoute direct customer if you want to bypass the gateway going to private endpoints. And even then, that's currently in a preview state today. There's some more information later on in the document. So if you're an ExpressRoute partner customer with a regular ExpressRoute circuit via Equinix or AT&T or Singtel or somebody like that, then private link won't work regardless, not even in a preview state. The next one we've talked about already, you need to have the top level gateway SKUs to turn this on at the connection level. This one here around basic load balancer is one to watch out for. And that's because there are some services on Azure, perhaps not your own service that's using basic load balancer, but does use basic load balancer behind the scenes. And within the VNet FAQ, there's a list here of things. Just this week, I came across a customer running HD Insight, trying to use FastPath. And again, because the service currently uses basic LB, you need to watch out for that. What that means effectively is if you enabled FastPath and you try to access a service fronted by a basic load balancer, then that traffic would just flow through the gateway. Again, private link, we've mentioned that already. You need to be using a 100 gig ExpressRoute direct circuit. Some IP address limits. Effectively, this means that the number of IPs that live inside your virtual network. You can see those sort of scale limits differ based on the type, whether it's ExpressRoute Direct 100 gig or 10 gig or a regular ExpressRoute circuit. Let's go on to public preview. So these are things that will work, but are within a public preview state, which means you can get support, but there's no SLA, and we don't recommend it for production. So first one is VNet peering. Of course, that's quite a big one, right? So that means is if you're coming into the VNet and you're trying to bypass the gateway, if ultimately you're trying to get to a service that lives in a spoke VNet, then that will work, but that's only in a public preview state. So again, we don't recommend that for production workloads. So the workaround there would be either put a gateway in the spoke or bring your application into the hub. Similarly, for UDRs, if you're coming into Azure, into that gateway subnet, and the gateway subnet's got a UDR that says go to the firewall, then that traffic is also subject to the same public preview stipulation. So that traffic will work via FastPath, but that's within a public preview state. Effectively, that means if you want to have the GA support tick in the box, you need to take your firewall out of the flow. And then again, we talked about the private link stuff already. Okay, so we understand the service, we understand some of the constraints that we have to work with today. Let's think about some customers that have used this service to improve their experience on Azure. First one is a customer that was accessing private endpoints from on-prem. They had a 100 gig circuit and they wanted really high throughput to Azure storage that kind of hung off the side here of this private endpoint. They were using the right gateway SKU. They enabled FastPath on this connection here, and that meant traffic started coming into their 100 gig ExpressRoute Direct port, started traversing directly to the private endpoint, and as we saw before, they had to be an ExpressRoute Direct customer at 100 gig to use FastPath for this scenario, but that definitely improved their performance. Of course, the 100 gig port is a huge amount of disparity to a 10 gig gateway, so bypassing the gateway was a great advantage for them. Next customer, they were coming from on-prem into a circuit, a regular partner circuit, into their gateway that lived inside of a hub virtual network, and then traversing VNet peering, go into a collection of very large virtual machines in the spoke that were running a voice workload. And they had a couple of things they wanted to do. They wanted to get as low latency as possible and get as many packets per second as possible. So they wanted to bypass the gateway to do that. This use of FastPath, so they enabled FastPath on this connection here. This use of FastPath going across VNet peering is classified as a preview state. So what they did was, on this VNet peering connection to their existing hub, they disabled the box for use remote gateway, and they deployed another ExpressRoute gateway inside of the spoke for the actual application owner. They then connected that gateway straight to their circuit and enabled FastPath on that connection. At that point, they were coming into the circuit, going across a FastPath enabled connection into a gateway and into their voice workload on a very large virtual machine. This meant that they were not using VNet peering to get to the destination, so therefore they were using FastPath in a GA state, and this greatly improved the packets per second they were getting to their voice application farm. Okay, third scenario, and this is an interesting one because it uses not a on-premises ExpressRoute connected site, but it's using Azure VMware solutions. AVS uses ExpressRoute inside of Azure for connectivity. So this customer was an Azure Virtual WAN customer, and that's how they connect all of their spokes into their landing zone. One thing to consider today, the gateways inside of Virtual WAN. So imagine you've got an ExpressRoute gateway here. Those gateways do not support FastPath on the connections today. That's coming in the future. This customer had a spoke VNet with, again, a very large collection of VMs with lots of vCPUs requiring very low latency to get to the collection of servers hosted on AVS. And because all of this is happening inside of the same Azure region, the latency was already low, so any incremental difference, even if it was a few tenths of a millisecond, made a big difference. So what this customer did to get around the limitation with Virtual WAN is they put this virtual machine here into its own VNet with its own gateway, enabled FastPath on the connection, and connected that into the AVS circuit. The result, this collection of very large SQL VMs running on native Azure IaaS talked directly to the routers that front AVS, which then passed the traffic onto the back end. This was actually a multicast enabled app inside of AVS, and they were getting around 2 millisecond end to end. FastPath saved them about half a millisecond. The final scenario I want to highlight is around the inter-CSP scenario. So as I talked about before, we do offer a service where you can run ExpressRoute and FastConnect back to back without using either your equipment or a partner. This is an agreement between Oracle and Microsoft. Generally what you find in these scenarios is customers put some sort of Oracle workload over here in ACI. Quite often it's a database of some kind, a backend. On the Azure side, they host perhaps middle tier or the front end. These two parts of the application need to talk to each other between CSPs that are very close geographically across this partnership. And one of the things that you can do there is you can enable FastPath on the connection here between the ExpressRoute circuit and the gateway to effectively bypass that. Again, you'll be looking at around about 0.5 millisecond saving there. In fact, Ben and I, so Ben is a engineer at Oracle, we made a video a couple of years ago where we showed the setup of this end-to-end, including FastPath. I will leave a link to the video in the comments. Okay then, I hope you found that useful. I hope you now can articulate what FastPath is. Hope you understand a little bit about the data plane, control plane behind the scenes, and I hope that use of customer scenarios helped you sort of visualize it and cement it in your brain. Thanks for watching. I'll speak to you soon.